Hello, everybody, and welcome back to our discussion on surveying. We are still talking about traversing and traverse measurements. More specifically, we are talking about traverse adjustment. And in the previous video, we talked about one of the methods of traverse adjustment, which is the compass method. For this video, I am going to talk about the transit rule for traverse adjustment. So, a transit rule is a method of traverse adjustment where the latitude and departure corrections depend on the length of the latitude and departure of the course respectively. Okay, so parehas yung transit rule parehas lang ng compass rule. The only difference here is that for the compass rule, the correction for each latitude and departure depends on the length of the line and on the total length of the traverse. Whereas dito sa transit rule, nakadepende yung correction natin doon sa latitude. Kung correction sa latitude, nakadepende sa latitude ng line at nakadepende sa total arithmetic sum of the latitudes. Okay? So kung latitude ang pinag-usapan, latitude lang. Hindi nakikialam yung departure. Okay? Ganon dito sa transit rule. So, in the compass rule kasi, the distance, the total distance yung ginagamit natin. Dito sa transit rule, kung latitude, latitude lang. Kung departure, departure lang. Okay? So the correction to be applied to the latitude or departure of any course is equal to the latitude or departure of the course multiplied by the ratio of the total course in latitude to the arithmetical sum of all the latitudes of the traverse. Okay? This statement can be represented by these two equations here. So we have the latitude of the course times the closure of the latitude divided by the arithmetic sum of the two latitudes. Dito naman sa departure times the closure departure divided by the total sum of the departures. All right? To illustrate the formula given, let us answer this problem. Given in the accompanying tabulation are the observed data for a traverse obtained from a transit tape survey. Determine the latitude and departure of each course and balance these quantities by employing the transit rule. Then, determine the adjusted length and adjusted azimuth of each course and tabulate values accordingly. So our table is given. We have three columns. For the first column, we have the course. The second column, we have the distances. And for the third column, the azimuth of these courses from the north. So to solve for the latitude of each course, we are going to employ the formula latitude is equal to the length of the course times the cosine of the alpha. Okay? Yung alpha dito, pwede na natin gamitin yung given dito sa table because this is azimuth from the north. Remember? We can directly use this formula to solve for the latitude. Ibibigay na niya kung positive or negative. Basta kunin na lang natin yan as the cosine of whatever this angle is. Hindi natin pag-iisipan kung positive or negative. Kusa ng ibibigay ng formula na ito. Okay, so let us solve for the latitude of each course. Una, we have latitude of AB. So the latitude of AB is equal to the length of AB times the cosine of the azimuth from the north. So we have 495.85 multiplied by the cosine of 5 degrees, 30 minutes. Okay, that's 495.85 meters multiplied by the cosine of 5 degrees, 30 minutes. And we come up with a positive value that is positive 493.57 meters. All right. So for the next course, we have latitude of BC. The length of BC is equal to 850.62 multiplied by the cosine of 46 degrees, 02 minutes. Okay, if we multiply that one, we come up with positive 590.53 meters. Next, for the next course, we have the latitude of CD. The latitude of CD is equal to the length of CD, 855.45, multiplied by the cosine of 112 degrees, 22 minutes. And we come up with negative 325.53 meters. Next, let us go to the next course, the latitude of DE. Latitude of DE is just equal to 1020.87 multiplied by the cosine of 167 degrees 35 minutes, and we come up with negative 996.99 meters. Next, for the latitude of EF, this is equal to the length of EF, 1117.26 multiplied by the cosine of 263 degrees 44 minutes, and we come up with negative 121.96 meters. And finally, for the latitude of the last course FA, this is equal to 660.08 meters multiplied by the cosine of 304 degrees 51 minutes, which will give us positive 377.19 meters. So those are the computed latitudes for this example. Next, we shall solve for the departure of each course, and for this we are going to use the formula departure is equal to the length times the sine of the given azimuth from the north. Okay, so let us solve for the departure of AB. Okay, so the departure of AB is equal to the length of AB, 495.85 multiplied by the sine of 5 degrees 30 minutes, and we should come up with positive 47.53 meters. Okay, for the departure of BC, this is equal to the length of BC, which is 850.62 multiplied by the sine of 46 degrees 02 minutes. We come up with positive 612.23 meters. Okay, for the departure of CD, we have 855.45 meters multiplied by 100 sine of 112 degrees 22 minutes. We should come up with positive 791.09 meters. All right, for the next one, we have departure of DE. The departure of DE is equal to the length of DE, 1020.87 meters multiplied by the sine of 167 degrees 35 minutes, and we should come up with positive 219.51 meters. For the departure of EF, this is equal to the length of EF, 1117.26 meters multiplied by the sine of 263 degrees 44 minutes. The departure of EF should be equal to negative 1110.58 meters. And then finally, for the last course FA, the departure of course FA is equal to 660.08 meters multiplied by the sine of 304 degrees 51 minutes, and we should come up with negative 541.70 meters. Okay, so these are the computed departure of each course on the closed traverse. So after determining the latitude and the departure, we can now tabulate the result using this table. All right. So these are the given. The first three columns are the given. So we have the computed latitude, separate column for the positive north and the negative south. We also have separate columns for the positive east and the negative west. As you can see, the sum, the last row, the sum of the positive north is 1461.29. This is actually our summation of north latitude, summation of NL. This one is the summation of south latitude, summation of SL. We just need the sum of the positive north and the negative south. This one is our summation of the east departure, and this one is the summation of our west departure. Okay, as you can see, there is a gap between the north latitude and the south latitude. And we also have a gap between the east departure and the west departure. So we can say there is an error of closure. Okay, based from that, we can now compute for the error of closure. Okay, so we need to write here the summation of NL and summation of SL. Okay, this is given in the table already by summing the north latitude, which is equal to 1461.29, 1461.29, and for the south latitude we have negative 1444 0.48 meters. Okay, these are our north latitude and south latitude. The summation of east departure is also given in the table to be positive 1670.36 meters, and for the west departure we have negative 1652.28 meters. All right, now we can compute for the total closure in latitude and departure. So the total closure for latitude is just the difference, or I mean arithmetic sum, because the south latitude is already negative. So this is arithmetic sum. Basically, this is summation of NL plus the summation of SL. Okay, so this is actually equal to 1461.29 minus 1444.48, which will give us the total closure in latitude at positive 16.81 meters. Okay, on the other hand, the total closure for the departure is just equal to the summation of east departure plus the summation of west departure. Basically, this is just the difference, 1670.36 minus 1652.28. And we will come up with positive 18.08 meters. So we have computed for the total closure in latitude and in departure. Now that we have computed for the total closure for latitude and the total closure in the departure, we can now determine the correction for each latitude, for each course, and then later on we can adjust each latitude. All right, so let us solve for the correction of the first course AB. The correction of AB is equal to the latitude of AB. Let us write here. The latitude of AB is 493.57. It's here. Okay, we have computed that. The latitude of AB is 493.57 meters. So that's 493.57 meters multiplied by the total closure in the latitude. That's C sub L. That's 16.81. Okay, 16.81, and then divided by the sum of the north latitude and the south latitude. Okay, this is the absolute value. Ibig sabihin, we do not mind the sign. I-add natin silang dalawa. Okay, the summation of the north latitude and the south latitude, that's 1461.29 plus 1444.48. Okay, so this is the summation of their absolute values. This is 1461.29 plus 1444.48. Okay, so that's the correction for AB. So the correction for AB is equal to 2.86 meters. All right, let us take a look at our formula. Our formula is composed of C sub L divided by the summation of NL plus SL. Okay, as I was saying, ano ito, C sub L tapos itong summation of north latitude plus south latitude, this is actually constant. Okay, constant yan. Ibig sabihin ito, minumultiply lang natin by the latitude of the given course. Okay, so ang gagawin natin dito, ang gagawin ninyo, i-compute na ninyo ito. 16.81 divided by ito 1461.29 plus 1444.48. And then, i-store na ninyo ito sa calculator ninyo. Gagaya ng ginawa natin sa compass rule, pwede nyo nang i-store yan sa kung anumang variable ang gusto nyo. Okay? So, bali ang gagawin na lang natin, whatever the value of this one, minumultiply na lang natin doon sa latitude of kung ano man yung sinusolve natin na correction. I hope you get that one. So, let us go to the next course. Correction naman for BC. Okay? Since alam na natin ang value nito, naka-store na sa calculator ninyo, kung ano man yung value niyan, i-multiply na lang natin sa latitude ng BC. The latitude of BC is 590.53. Okay? So, kapag minultiply natin ito, 590.53 by the value of 16.81 divided by this, ang lalabas na sagot is 3.42 meters. Okay? For the correction of CD, the latitude of CD is 325.53. Do not mind the negative sign, ano? Itong absolute value ang gamitin natin. Absolute value of this one. So, 325.53 multiplied by ito. Okay? So, ang lalabas na sagot dyan ay 1.88. So, we have 1.88 meters. And then, for the correction of DE, the correction of DE is 996.99. Ito, 996.99 multiplied by this one is equal to 5.77 meters. The correction for EF is just equal to 121.96 multiplied by the value of this one, that is equal to 0.70 meters. And finally, the correction for FA is equal to the latitude of FA, which is 377.19 multiplied by the value of this one, and that is equal to 2.18 meters. Now, these are the corrections of the latitude. Okay? Next, now that we have determined the corrections to be employed to each of the latitudes, o pwede natin yun gawin. I-adjust na natin yung mga latitudes. Okay, let us adjust each latitude. Remember, if we go back to the arithmetic sum of dito, so north latitude and south latitude, kung titignan natin, mas malaki yung north latitude kumpara sa south latitude. 1,461 for the north latitude, 1,444 lang dito sa south latitude. Okay, para mag-close ito, ang goal natin kasi dito is to balance. Gaya ng sinasabi ko, dapat the difference of these two is equal to 0. Ang gagawin natin dito is to subtract the corrections from the north latitude, tapos mag-a-add tayo dito sa south latitude. Alright? Para ma-close yung gap nila. Okay? Okay, so we are now ready to adjust the latitudes. Okay, for the first one, the corrected latitude for AB. Our symbol for that one is lat of AB. Okay, lat of AB. Pero lalagyan na natin ng prime. Okay, this is the adjusted latitude for AB. This is equal to the original latitude of AB. Ano na yung original na latitude ng AB natin? Ayan, given 493.57. Since this is north, I mean positive, magma-minus tayo, okay? So magma-minus tayo ng correction. Ano ba yung correction na na-compute natin? 2.86. So subtract natin yung 2.86. So dito ay 493.57 minus the correction of 2.86, which is equal to positive 490.71 meters. Okay? For the next one, for the adjusted latitude of BC naman, the original latitude of BC is equal to 590.53. This is also positive, so we are going to subtract the correction. Ang correction na na-solve natin for BC is 3.42. Okay, so this one, the corrected latitude for BC is 590.53 minus the correction of 3.42, which is now equal to positive 587.11 meters. Next, for latitude of CD adjusted, so the original latitude of CD is negative 325.53. Okay, so we are going to add from 325.53, yung absolute value nito, we are going to add the correction. Okay, we are going to add the correction na for CD, that's 1.88. Okay, so basically, for the adjusted latitude of CD, we are going to have negative of 325.53. I-add natin yung correction na 1.88. So this is equal to negative 327.41 meters. Okay, and then for the adjusted latitude of DE, the adjusted latitude for DE, the original latitude is negative 996.99. So we have negative 996.99, and we have to add the correction. The correction that we have computed is 5.77. Okay, so we should come up for the adjusted latitude of DE to be equal to 1002.76 meters. All right, and then we also have the adjusted latitude for EF. The original latitude of EF is negative 121.96. So we have 121.96, and we need to add the correction of 0.70. Okay, we should come up with negative 122.66 meters. And then finally, for the adjusted latitude of FA, this is equal to positive 377.19. This is the original. Okay, we need to subtract, because this is positive, we need to subtract the correction of 2.18. So we have positive 375.01 meters. All right, so this is now the adjusted latitude of each line. Remember to check if your adjusted latitude is correct. We need to get the algebraic sum of all of these. Yan, taking into consideration yung mga signs nila, dapat the sum should be equal to 0. Okay? The sum should be equal to 0. Okay, those are our adjusted latitude for each course. Next, let us solve for the correction of each departure naman, and then later on we will adjust the departure. Okay? So, kagaya nung sa latitude, dito naman, itong C sub D divided by the summation of ED plus the summation of WD, ito naman ay constant. Okay, so you can solve that one immediately and store it somewhere in your calculator. Say B, C, or D. I-store nyo yan para ito na lang yung imumultiply natin sa departure ng bawat course. Okay, so let us start with the departure of AB. Okay, so the departure of AB, I mean the correction at AB, I'm sorry. the correction at AB is equal to the departure of AB. The departure of AB is given, and it's here. The departure of AB is 47.53 meters. Okay, so we have 47.53 meters. Sulat natin yan dito. We have 47.53 meters multiplied by the total correction, total closure in the departure. Ito, C sub D. That's 18.08. Okay? Times 18.08 meters divided by the summation of the absolute values of ED and WD. So, galing naman dito dyan. Summation ng ED tsaka WD. That's 1,670.36 plus 1,652.28. Okay, so that's 1,670.36 plus 1,652.28. Okay, and we should come up with 0.26 meters. Okay, I reiterate, ito pwede nyo nang isolve minsanan. Ito i-store ninyo sa calculator ninyo para i-multiply na lang natin sa bawat departure ng bawat course later on para mas madali na yung pag-solve ninyo. Okay, so let us go to the correction naman, correction of BC. Okay, so i-multiply lang natin ito by the departure of BC. The departure of BC is 612.23. Okay, multiplied by itong value na to, and we should come up with 3.33 meters. Okay, for the correction of CD naman, the original departure of CD is 791.09. Multiply lang natin dito sa value, this value, and we should come up with 4.31 meters. Okay, to compute for the correction of DE. The correction of DE, the original departure of DE is 219.51 multiplied by the value of this one, and we should come up with 1.19 meters. Next, for the correction of EF, okay, the correction of EF is equal to 1,110.58 multiplied by the value of this one, and we should come up with 6.04 meters. And then finally, for the correction of FA, we multiply the value of this one by 541.70, and we should come up with 2.95. We should come up with 2.95 meters. So these are our corrections for the departure. Now we are ready to adjust the departure for each course. Okay, so let us now adjust the departure for each course. First, let us adjust the departure for AB. But before we do that, let us try to analyze what's happening with the departure. The east departure is the sum of the east departure is 1670.36 while the sum of the west departure is 1652.28. Mas malaki itong east departure, that is why we are going to subtract from the east departure itong positive, and we are going to add dito sa west departure. Okay, so that's what we will do for the adjusting of departure. The original departure for AB, okay, so departure of AB now adjusted. Okay, the adjusted departure for AB is equal to the original departure of AB, which is positive 47.53. It should be there along our calculations. Ito, 47.53. And we are going to we are going to subtract the correction na 0.26. Okay, yung mga positive na departure, subtract the correction. Okay, so we have 47.53 minus 0.26, and this should be equal to positive 47.27 meters. Now, for the adjusted departure of BC, the original departure of BC is positive 612.23. Okay, so positive 612.23, we need to subtract the correction of 3.33. Okay, and we should come up with positive 608.90 meters. Next, for the departure of CD, the adjusted departure for CD, the original departure for CD is positive 791.09 meters. So we need to subtract the correction of 4.31 meters, and we should come up with 786 plus 786.78 meters. Next, for the departure of DE, adjusted departure for DE, the original was 219.51. So that's why we need to subtract the given or the computed correction of 1.19, and we should come up with positive 218.32 meters. For the departure of EF, okay, the adjusted departure for EF, the original was negative. Okay, we have negative 1,110.58. Okay, since this is negative, we are going to add the correction of positive 6.04, and we should come up with negative 1,116.62 meters. And then finally, for the adjusted departure of FA, the original departure is negative 541.70. So we need to add the correction of 2.95, and we should come up with negative 544.65 meters. All right. So for this one, to check if your adjusted departure are correct, we need to get the sum, and we should come up with a 0. Okay, so that's it. We have adjusted for the departures of the given traverse. Now that we know the adjusted latitude and adjusted departure of each line, we can now determine the adjusted length and bearing for each course. Okay, so first, for AB, okay, so the adjusted length of AB, is equal to the adjusted latitude of AB, square root, ano? This is square root of the adjusted latitude of AB. This one, adjusted latitude of AB is 490.71 meters. Okay, that's 490.71 meters square, plus the adjusted departure of AB. Dito, the adjusted departure of AB is 47.27 meters. Okay, so that's 47.27 meters square. Right, this is Pythagorean theorem. Okay, so the adjusted length for AB should be equal to 492.98 meters. Okay, that's 492.98 meters. Okay, we do the same for the remaining length. So the adjusted length of BC is equal to the square root of the adjusted length of latitude of BC square plus the adjusted latitude or departure of BC, 608.90 square. Okay, just like what we did here, and we should come up with 845.85 meters. And then, for the adjusted length of CD, we will do the same. That's square root of 327.41 meters square plus 786.78 square. And we should come up for the adjusted length of CD equal to 852.19 meters. For the adjusted length of DE, okay, so the adjusted length of DE, if we employ the same formula, we should come up with 1026.25 meters. Okay, for the adjusted length of EF, using the same formula, we should come up with 1123.34 meters. And finally, for the adjusted length of FA, we should come up with 661.27 meters. So these are the adjusted length for each course. Next, let us determine the adjusted bearing for each course. This is our formula. The theta, or the adjusted bearing, is just equal to the inverse tangent of departure divided by latitude. Okay, so let us start with theta AB. So theta AB is just equal to the inverse tangent of the departure. The given departure was positive 47.27 divided by the latitude. This is the adjusted, departure divided by adjusted latitude of 490.71 meters. So if we calculate this one using your calculator, we should come up with 5 degrees 30 minutes. Okay, so this is the azimuth of AB. Next, for theta BC. Theta BC is just the inverse tangent of 608.90 divided by 587.11. And we should come up with 46 degrees 03 minutes. Okay? So, this is also the azimuth now because it's from north to east. Okay? That's northeast. That is also northeast. Remember, the azimuth is from the north. Ganyan siya. Okay, so yung ano natin, itong 5 minutes, 5 degrees, ito lang siya. So kung positive yung north numerator at positive yung denominator, whatever the bearing, whatever we have computed dito, yun na yung azimuth mismo. Okay, so yan na yung azimuth for AB, yan na rin yung azimuth for BC. For the next one, we have CD. Theta CD, we have inverse tangent of positive 786.78 divided by the negative 327.41. Okay, yun yung departure, the adjusted departure and latitude. And we should come up with 67 degrees 24 minutes. Meron tayong konting problema dito. No? Isulat natin. Okay? Isulat natin yung given. Okay? This is inverse tangent of positive 786.78 divided by negative 327.41. We have a positive departure tapos negative latitude. At ang lumabas dito ay 67 degrees 24 minutes. Now, how do we come up with the azimuth? Okay, remember itong angle na to comes from a positive x-axis. Positive yung departure niya, pero negative yung kanyang latitude. So nandito yung angle na yan. Okay? Ito mismo yung angle na yan. Yan. Nandyan yung theta. Okay? Kasi nga positive yung departure, negative yung latitude. Parang positive x, negative y. So nasa fourth quadrant. At saka yung theta palaging nasa vertical, palaging from the vertical. So nandito yung theta natin. So how do we come up with the azimuth? Therefore, the azimuth is this one. Okay? That's 180 minus whatever that is. So that's 180 degrees minus 67 degrees, 24 minutes. And we should come up with an azimuth of, for CD, the azimuth is 112 degrees, 36 minutes. This is the azimuth. Okay? Remember that. Hindi palaging yung ano na yung sagot, yun na yung azimuth for this case. Okay? Next, for theta DE. Theta DE, we have inverse tangent of positive yung, sulat na lang natin para makita nyo. 218.32, positive yan. Tapos negative dito sa baba na 1002.76. And we will come up with 12 degrees, 17 minutes. Okay? Remember ulit dito, nasaan yung theta natin? Ano? Positive yung departure, ibig sabihin dito sa positive dito, tapos negative pababa. So, nandyan ulit yung theta. Okay? In this case, parehas lang. That's 180 degrees minus 12 degrees, 17 minutes. Ito na ngayon yung azimuth natin should be equal to 167 degrees, 43 minutes. This is the azimuth. Okay? For the next one, we have theta. Ano yung last natin? DE. We have EF. Okay? For theta EF, we have inverse tangent of, parehas na negative ito. Negative 1,116.62 divided by negative 122.66. And we come up with 83 degrees, 44 minutes. Okay? So, titignan natin yung angle na yan. Saan yung angle na yan? Negative yung departure, negative din yung latitude. So, nasa third quadrant, ditong quadrant na to. So, nandito yung theta natin. So, to come up with the azimuth, ito yung azimuth natin. So, we should add 180 degrees to this one to come up with the azimuth. So, 180 degrees plus yung 83 degrees, 44 minutes na yan. And we should come up with 263 degrees, 44 minutes. Ito ngayon yung azimuth. Okay? And then finally, for theta FA. For theta FA, we have inverse tangent of negative 544.65. Okay, and then divided by positive 375.01. Okay, and we should come up with an angle of 55 degrees, 27 minutes. Okay? So again, negative, i-illustrate natin para makita nyo. Negative departure, positive yung latitude. So nandito siya sa quadrant na to. And this angle is always from your vertical. So nandyan yung theta. So to come up with the azimuth, i-minus natin yung theta na yan from 360 degrees. Okay? So 360 degrees minus this theta, 55 degrees, 27 minutes. We should come up with 304 degrees, 33 minutes. Ito na ngayon yung azimuth for FA. Alright? So, tapos na tayo sa mga adjusted na azimuth for each line. Nakita na natin yan, yung mga adjusted. Now, ang susunod, i-fill up na natin itong table na to kasi kompleto na tayo ng data. Meron tayong correction for each course, the adjusted latitude, the adjusted departure, and then the adjusted length and adjusted azimuth. Azimuth ito. Okay, let us try to change this one. We have the adjusted azimuth. Okay, let us try to fill it up and then tanan, it's already been filled up. So, nandyan na. Lahat na ng sagot natin kanina na fill up na dito sa table. Okay? So, understand the table. And let me know kung meron kayong hindi naintindihan. Comment on the video below, okay? Thank you very much for listening. That's it for the transit rule. See you in the next video.